Good. Okay. All right. So, our plan for today is to kind of keep plodding along through this section. I'm going to start with taking questions, and then this week, at the end of our first week, I sometimes I like to kind of throw it out to the class to see if we want to have a quiz the very first week or wait until the second week. I'm going to give you the pros and cons of each choice. If we have a quiz on Friday, then it'll cover just what we did this week, so it covers less material. If we wait until next week, it'll cover more stuff, obviously. So you might be better able to target your reviews if we do one this week, but obviously a week with no quiz maybe also sounds nice. So do you have thoughts on that? This week? Okay. So quiz Friday on this week's material. Okay, great. So then, are there questions? Does anybody have questions they'd like to ask on the stuff we did on Monday? That first section, any of the practice exercises or examples that you have questions about? Okay. All right then. Then we'll go ahead and get started. We're going to get through for sure the section on the straight line, which is really short and stuff that you probably already know. And then we're going to do the circle, which maybe is some newer stuff. I don't know if you've done a whole lot of standard equation for the circle. And then depending on where we are on time, we'll get to start talking about the parabola. So let's begin. So, the equation for a line comes in a few different forms. Here's the one that we probably are most familiar with, the slope-intercept form, y equals mx plus b, where m is the slope of the line and b is the y-intercept. It can be convenient for sketching a graph. So, let's say we want to sketch a graph of this line. If we first get it into slope-intercept form, which we could do just by solving it for y, so we could throw the 4x, subtract 4x, add 6 to both sides. And then we've got 2y equals negative 4x plus 6. And then the last thing to do is just divide by 2. Y is negative 2x plus 3. So in the slope-intercept form, we can identify the slope, which is negative 2. If the slope is a whole number, I like to write it as a fraction so I could really see it as the rise over run. I know that means we're going to go down 2 over 1 to get a new point from an existing point. And the y-intercept is the point 0, 3. So from here, we're ready to plot a point. The y-intercept is like a point we get for free, right? So it goes through that point, and if I know the slope, I can use it to obtain another point. So down 2 over 1 puts us here. We could even do another one. Down 2 over 1, and there we get a nice line. Of course, you only need 2 points to make a line. So, there's the slope-intercept form. My favorite equation for the line, my favorite form of the equation usually is the point-slope form. It's really useful for finding the equation of a line, because all you need, if you know the slope and you know any point that it goes through, not just the y-intercept, but you know any point it goes through, you can make an equation of the line using this point slope form. So it looks like this: y minus y1 equals m times x minus x1. It's really just, you know, if you take the slope formula, y2 minus y1 over x2 minus x1, and then you say, okay, I've only got one fixed point, right? x1, y1, that's the point I know. For any other point, x, y, that might be on it, so if I drop that subscript, the 2 subscript, all you do is just, you know, if I multiply both sides by x minus x1, there's your point slope form. So that's where it comes from. It is useful for finding the equation of a line. I'm going to scroll on to the next page. If you're still writing or need me to stay, let me know. In this example, they want us to find the equation of a line passing through a couple of points. If I have 2 points, I can, of course, find the slope. So we'll do that. So y2 minus y1 is 2 minus a negative 1, 2 plus 1, and then x2 minus x1 is 6 minus 2. So we get 3/4. Positive 3/4 for the slope. And now we're pretty much ready to find the equation of a line. I'm going to start with the point slope form. Y minus y1 equals m times x minus x1. We figured out the slope, and then we just need a point. They gave us 2 points. You could pick whichever point you want to use. Either of them will work just fine. I'm going to go ahead and pick the one that I labeled x1, y1. So y, that would be y plus 1 is equal to 3/4 times x minus 2. Now, this question just says find the equation of the line. We did. There's the equation of a line. We left it, in this case, I've got it written in that point slope form. If it doesn't specify, it's okay to leave it there. If you like, or if it asks you to put it in, say, slope-intercept form, all we do is solve it for y. We distribute the slope. 3/4 times 2 is 3/2. And then subtract 1. 3/4 x minus 5/2. Either of these is fine. If I don't, you know, if you're not instructed on like a quiz or a test, if I don't instruct you specifically to use a particular form, then you can leave it in either form. What you're often going to see in the back of the book, mostly because I think it fits conveniently on a page and maybe takes up less space, is for them to use what we call the general form for the equation of a line. And with the general form, it's not just for a line, like the general form for the equation of a line or a parabola or a circle or an ellipse or whatever. Generally, it's like everything's all distributed out, and you collect all your terms on one side so that it's set equal to 0. And you clear denominators. So, we're, you know, a, b, and c in this case would be integers. So up here, if I took this equation and often the first thing I'll do is clear denominators because I find that convenient. You could do that last if you want to, but I often do it first. So if I multiply both sides by 4, and on that side it just cancels the 4. Here we have 4y plus 4 equals, I'll distribute this 3, so we get 3x minus 6. And then I can just collect all terms on one side. So if I subtract 3x and add 6, we would get negative 3x plus 4y plus 10 equals 0. I don't find that to be a particularly useful form. I don't, as a matter of course, choose to write my lines in that form. Like the slope-intercept form gives me like an immediate sense of, oh, I know the slope, I know the y-intercept, I know what it looks like. The point-slope form, same thing. This doesn't give me that same insight, so I usually don't just pick that form to put my line in, but I know that if I'm like doing a problem and I'm checking in the back of the book, there's a pretty decent chance they're going to put the equation in that form because it just fits easier and takes up less space. One thing about the general form is that since it's set equal to 0, if I multiply both sides by -1, then it's still set equal to 0, and they're still integers. So this would look like 3x minus 4y minus 10 equals 0. These are both general form, right? So like whether you choose to start off with a negative x coefficient or not, they're both general form. So you might see that variation as well. Quick remark, a vertical line is defined by having the same x coordinate no matter what y is, so that looks like x equals a, and a horizontal line is defined by having the same y coordinate no matter what x is, and so that equation looks like y equals b. Another example here, we're going to find the general form. So in this case, they're specifically asking for general form of the equation of the line, and they'd say it passes through the point -1, 2 and is parallel to this line they gave us. So I have a point. They gave me a point. Do I have the slope? How do we find the slope? Say that louder. Solve for y of the given equation? Yeah, right. So if we could find the slope of the line they gave us, then our slope is just the same because it's parallel. So let's find that slope. We'll subtract 3x and add 6. So dividing by 2 gives us -3/2 x plus 3. So the slope of the line they gave us is -3/2. That means that our slope is -3/2 as well because it's parallel. Now, they want us to get the equation in general form. I'm going to worry about that at the end. If I'm going to find the equation of a line, I personally am going to use the point-slope form. I like that form, or I like that for finding the equation of a line. Some people really like using slope-intercept always, so like, you know, we know the slope and then you can use the point to figure out what b is. That's fine. But just whichever form you want to use it to get the equation, and then worry about getting it in general form at the end. So we know this point here, let's see, y minus 2 is -3/2 x plus 1. We want it in general form, so I'm going to clear denominators first. I'll multiply both sides by 2. That'll cancel that 2. So now I'll distribute what's left. So we have 2y minus 4 equals -3x minus 3. And then I'll gather all of my terms on one side. So add 3x, add 3. And we get 3x plus 2y minus 1 equals 0. How's that? Are there any questions on this example or the previous one before we talk about circles? Okay. All right. So we know, geometrically what a circle is, right? So you fix a point. We call that point the center. Then you fix a distance, which we call the radius. And it's all the points that are that distance from the center, right? So the center is not a point on the circle, but it's used to define the circle. And a circle with the center at the point HK and radius R will always have a standard equation that's equal to x minus h squared plus y minus k squared equals r squared. This is a standard form because we could tell just by looking at the equation what the center and radius are, right? Like the equation itself gives us an immediate, like, kind of geometric insight into what this looks like. Whereas if I imagine like foiling out, like multiplying everything out in that equation, that wouldn't really be particularly helpful. We could see why this is the standard form pretty easily, or we could derive this equation ourselves. So here's a generic, there's a circle, the center is HK, the radius is R, and then this point P is just any old arbitrary point. I could have drawn that point anywhere, really, on the circle, but there it is up there, that point XY. And the point on the circle is just defined solely by its distance to the center. That's what it makes it a point on the circle. So we're going to use that sort of geometric definition to derive the equation. This is what analytic geometry is all about, is making connections between the geometric information, how we define something geometrically with distances and points and stuff, and then translating that into algebra. So if we draw the perpendiculars, which is one of our favorite things to do in the plane, we create, of course, this nice right triangle. And now we've created a new point. Here's a point of interest, obviously, where those two lines intersect. What are the coordinates of this point in terms of the points that we already have there? Say that again. So I think I heard K for the Y coordinate. Yeah, yes, XK. So you got to say it like you mean it. I guess that microphone is like way up at in the front. So yeah, so there's the coordinates XK. And this at this point probably looks a little familiar because we did something like this on Monday when we were kind of deriving the distance formula. We could find these distances here. Here's a vertical distance. Recall that we get a vertical distance just by taking the top y minus the bottom y. So this distance is y minus k. The horizontal distance we can always get by taking the right x minus the left x. So that's x minus h. So now here we have a right triangle, and we have the distances or the lengths of all three sides of this right triangle represented. So we turn to Pythagoras again. Pythagoras tells us that if I add up the squares of the legs, so x minus h squared plus y minus k squared, that should give us the square of the hypotenuse, which is r squared. Okay, so we know why that's the standard form. It gives us, insight into what the circle looks like just by looking at the equation. So on the next page, maybe we'll gain an appreciation of that. This example asks us to find the center and radius of this circle. There will be very little work to do here, right? The center and radius of this circle are merely to be plucked from this equation. This is low-hanging fruit right now. What should, and one thing I'll draw your attention to is that if the center is hk, this equation is x minus h, y minus k. So the coordinates of the center are the things that we're subtracting inside the parentheses. And so with that information, what should the center be for this circle. One, -2. Yeah, so I just think of it as whatever these are, just switch the signs and grab those numbers. What about the radius? Yeah, the radius is 4 because we're just going to take the square root of that number on the right side. That's it. See, there's really little work. If something's in standard form, it's supposed to be easier, right? Like, there's not a whole lot to do. So the questions in this chapter kind of come in two overall categories, no matter what we're talking about, no matter whether we're talking about lines or circles or parabolas or ellipses or even some of the stuff in the last section. They come in a couple of forms. One form is like the one we just did. Well, they'll give us an equation, and they want us to figure out some geometric information. Like they gave us the equation, we want center and radius. The other kind is where we're going the other way around. They give us some geometric information, and they want us to find the equation. So in example 112, that's what we're doing. They tell us the center, the coordinates of the center, and then they tell us another point that it passes through. If they just told us the radius, that would be easier. But they told us another point it passes through. They want us to get the equation of the circle. So I'm going to just start by writing out, here's what the standard form of the equation of a circle looks like. They gave us h and k, right, with that the coordinates of the center. So what I know right now is that this is x minus 2 squared plus y minus 1 squared equals r squared. I just need to know what r squared is, and then I'll be done. Now, they tell us that it passes through a point that they give us. That is really good information, and throughout this chapter, and really throughout, in other chapters, as we look at other topics, here's a basic fact that we should always sort of keep in mind and be aware of and make use of when we need to. If we know the coordinates of a point that a curve passes through, we could plug those coordinates in for x and y. So if it passes through the point 4, 8, then we're going to substitute x equals 4, y equals 8 into the equation. So that looks like 4 minus 2 squared plus 8 minus 1 squared equals r squared. And now all we have to do is a little bit of arithmetic, and we'll know what r squared is. Then we don't even need to figure out r, right? All we need is r squared to plug that in, right here. So 4 minus 2 is 2 squared, that's 4. 8, 7 squared is 49. So that's 53. Is r squared. And that gives us now the equation x minus 2 squared plus y minus 1 squared equals 53. And there's our equation of the circle in standard form. How's that? Not bad. Okay. I'm going to scroll up to this last example that we did a second ago and just say, look, what if instead of giving us the equation in this form, right? If I take this equation, do some algebra on it, like I'm going to expand both of those squares. So we have x squared minus 2x plus 1 plus y squared plus 4y plus 4 equals 16. And I'm going to subtract 16 from both sides. So this is, and then I'm going to gather my terms. So I got x squared plus y squared minus 2x plus 4y. And then my constants are 1 and 4 is 5. 5 minus 16 is negative 11. What if they gave me this equation here and said, tell me the center and the radius? It'd be a lot harder, right? Like, there was very little work to do to get the center and radius when we have it in standard form. If just looking at that, the equation of that circle, I can't tell much about it other than it is a circle. And here's how you know something's a circle. If you're looking at an equation that's all multiplied out, if it's not in standard form. If it's all multiplied out like this, you know it's a circle because you have both an x squared and a y squared, and they both have the same coefficient, including the same sign. So if it was 2x squared plus 2y squared, and then some x's and y's or whatever, then I know it's still a circle. So what we're going to focus on now is, what if we get an equation that's not in standard form? How do we put it in standard form so we can find the center and radius? And in order to do that, literally we get to do like what is one of my absolute favorite things in the world. I could do this every day, all day, and be pretty happy, I think, for a long period of time. It's really, you know, I kind of zen out to completing the square. It's really kind of meditative. So the general form of the circle, so remember we were talking about this with the line. With the general form, it's, you know, everything's multiplied out. You collect all terms to one side. It's set equal to 0. The general form is convenient only if you want to be able to write the equation in a single line, and maybe you want trying to avoid fractions or something. But it's not useful. The general form is not useful as far as, like, it gives us no insight. So we want to be able to get an equation in standard form. Here's how it works. I've kind of written out a general procedure here, but we're going to just sort of see how this works with an example. So first of all, we want the constant. If there's a constant there, we want to throw it by itself on the other side. So let's add 24 in this example. Now, the next thing I'll do is, when I'm rewriting this equation, I'm going to get myself ready to complete the square. And here's how I do that. I've got that x squared term. I'm going to, the next term I'm going to write down is the x's. So minus 6x. Then I'm going to leave some space. And then I've got plus y squared plus 8y. And then I'm going to leave some space, equals 24. When we complete the square, we always want to complete the square on 1x squared, 1y squared, not 2x squared or 3x squared or negative x squared. So if the coefficient on the x squared and y squared is anything other than 1, you divide through by that to make sure you get a coefficient of 1. Right now we're all set, and we'll see an example where we need to do that in the next problem. So now we're ready to complete the square. So we're in algebra, right, working with equations, we are totally allowed to add the same thing to both sides, always, right? I could add 7 to both sides or subtract 11 from both sides. Those just won't be particularly helpful. I want to be clever about what I choose to add to both sides. So looking at the x's, the coefficient on x is negative 6. What I'm going to do is cut that in half, negative 3, square it. I want to add that to this side, because that's going to help us out. In order to do that, of course, I have to add it to this side. We're going to do the same thing with the y's. That coefficient on y is 8. I'm going to cut that in half and square it and add that to both sides. The reason that this is so clever is because now if I look at just the x terms, those 3 terms, including the plus negative 3 squared, that's a perfect square. That is a perfect square. Here's what a perfect square looks like. We just have to see what goes inside. And because we were clever in choosing this, I know I'm just going to grab that x. I'm going to grab this minus 3. So inside I've got x minus 3. And you could check this. If you FOIL out x minus 3 squared, you'll get x squared minus 6x plus 9, which is what we have up there. Looking at the next grouping here, that's a perfect square. Inside the parentheses, y plus 4. On the right side, we have some arithmetic to do. Let's see, 24 plus 9 plus 16 is 24 plus 25 is 49. This is the equation of the circle in standard form. That's one of the things they asked us for. And since we have it in standard form, we could figure out our center and radius. What's the center? And the radius? 7. Great. Are there questions on that example? Okay. Well, let's do another one then. We want to complete the square to get it in standard form. I know it's a circle because I've got an x squared and a y squared, and both of the coefficients are the same. They're both positive 4. The constant is already by itself on the other side. So I'm going to start out by making sure that I've got coefficients of 1 on the x squared and y squared. So I'm just going to divide through both sides by 4. That looks like x squared plus y squared minus 4y. I'm going to leave some space here. Equals 9/4. Now, one thing you might notice about this equation is that there's no plain old x term. There's no linear x term. I have an x squared, no x's, and it goes right to y squared. X squared is already a perfect square. There's no square to complete there. We could really see this x squared as x minus 0 squared. So we don't have any square to complete there, but we do have to complete the square on y. How do we do that? What's our next step? Yeah, add 2 squared to both sides. I always include the negative here. Now, of course, when you square, it's positive anyway, so do what you want. I include the negative when I write it down to remind myself, like, what's going to go in the parentheses on the next step. What is going to go, like, how do we write, what is that perfect square that we have with the y's? So this, let's see, on the right side, we've got 9/4 plus, that's 4, which is 16/4, so that's 25/4. So there's the standard form. And I wrote it as x minus 0 squared. If you left it as plain old x squared, that's considered standard form as well. I was just sort of driving home the point that that is, in fact, already a complete square. So here's our standard form. What is the center? And the radius? 5/2, yeah. So I'm just going to mention explicitly, you got that, of course, by taking the square root of 25/4. And you were allowed to split up a radical over division. And so that gives us 5/2. Are there questions on that example? Okay. All right. Well then, let's talk about the parabola. So we're going to start with the geometric definition. What define, you might when you hear the word parabola, you probably think, oh, that's like the graph of a quadratic, and it is. But we're going to start really from a geometric perspective, and a parabola is simply defined to be a set of points. So here's what you do: you fix a point, kind of like we do with the circle. We fix a point that's the center. We fix a point, we call it a focus, and then you draw a line, which we call the directrix. Now, the focus and the directrix are not on the parabola itself, but they help us define the parabola. And then you take all the points such that the distance to that fixed point, to the focus, is the same as the distance to the directrix. And that's what forms a parabola. If we look down here at the figure, here's the focus. This vertical line to the left is a directrix. And what makes this a point on the parabola is that the distance to the focus is the same as the distance to the directrix. So a distance from a point to a point, we already know about that. The distance from a point to a line always means the shortest distance. Because I could draw lots of distances from a point to a line, but it always means the shortest distance, which is a perpendicular distance. And in the case of, if our directrix is vertical, that means it's a horizontal distance. And that's why we simply subtract those x coordinates. So we're going to focus first, no pun intended, with a parabola that has a vertex at the origin. So the vertex of the parabola is just sort of the nose, right? The nose of the parabola. And if the focus, if the vertex is at the origin, we're going to look first at parabolas that are oriented horizontally. Then we find a focus, say at this point P0, and the directrix will be x equals negative P. Now, because if the focus is at P0, the directrix would have to be x equals negative P, because the vertex is a point on the parabola, and it has to be the same distance from the focus as it is to the directrix. So these distances, this distance has to be the same as that distance. So once we kind of have this sort of concept of saying, okay, I know what makes something a point on the parabola is that the distance to the focus is the same as the distance to the directrix, we're going to derive what the standard form looks like. They tell us, right, we're given the standard form. It's right here, y squared equals 4px. That's a nice simple equation that describes the equation of the parabola. But we're going to figure that out for ourselves. So if the distance to the directrix is p plus x, and the distance to the focus is this, which we get just by using the distance formula, we're just going to set these equal to each other. We know that x plus p is equal to the square root of x minus p squared plus y minus 0 squared. That equation certainly does describe the parabola. It's just not very simplified. So I'm going to get rid of the radical by squaring both sides. On the left here, I'm going to FOIL that out. I'm going to multiply that square. So x plus p squared is x squared plus 2px plus p squared. On the other side, we've got x minus p squared plus y minus 0 squared. And I'm going to FOIL both of those out. So let's expand those out. X squared minus 2px plus p squared plus y squared. And then I'm going to isolate the y squared. So the on the right side, I'm going to isolate the y squared. So I'm going to subtract x squared from both sides. I'm going to add 2px to both sides. And I'm going to subtract p squared from both sides. And when we do that, what we're left with is On the left, I just have 4px, and on the right, I've got y squared, and there's our standard form. So when we have, you know, again, starting with the parabolas that have their vertex at the origin, that's what we're working with now. If I have that equation, I know that if it's oriented horizontally, it looks like the equation will look like y squared equals 4px. What I get from that equation, and why it's the standard equation, is that the value p, I could figure out what the value p is, and that tells me where the focus is, and also where the directrix is. So if p is positive, then the focus is, the focus is over here for a positive x value, and it opens to the right. If p is negative, then the focus would be over here on the negative side, and it would open to the left. A parabola always sort of swallows up the focus and opens away from the directrix. Let's do some examples. Here they give us the equation y squared equals 12x. So if y squared equals 12x, that is in standard form. What I get from that is that 4p is equal to 12. And so p has to be equal to 3. P is a positive, so the focus is a positive 3, 0. And the directrix is always a line. So sometimes people say the directrix is -3. Really, the directrix is the line x equals -3. So if a parabola is oriented horizontally, the directrix is a vertical line, and we know that those have the equation x equals some constant. And they ask us to sketch it. So we know that the vertex is at the origin. Here's our focus. Here's our directrix, is this vertical line, which we draw dotted usually just because it's not actually a part of the parabola. It just helps define it. And I know it opens away from the directrix, so it's going to open to the right. Now, often what I do is just try to get one other point on the curve. You know, the parabola is always symmetric, right? So in addition to, I'm going to scroll up for a moment and look back at this, look back at the figure they gave us. In addition to a vertex and a focus and a directrix, a parabola is always symmetric, and it has this axis of symmetry, which if your vertex is at the origin and opens horizontally, in this case the x-axis is the axis of symmetry. So if I find one other point that's on it, I actually get 2 if I just sort of mirror it over the x-axis. So in this case, let's say I plug in x equals 3, then y squared is equal to 12 times 3, or 36. And so y is equal to plus or minus 6. So there's that point. And this point. And that just sort of, you know, getting another point on it just helps me draw a little bit more accurate sketch. Are there questions on this example? All right. Let's do another one. This time they gave us the equation y squared equals -8. Negative 8x, rather. So that's in standard form, right? It's of the form y squared equals some constant times x. And what we get from that is that 4p has to equal negative 8. And so this time p is negative, right? P is negative 2. That means the focus is negative 2, 0. The focus is on the left side of the vertex. And the directrix is going to be on the other side. So that's x equals positive 2. There's negative 2. That's the focus. Here's our directrix. We know the vertex is at the origin. We'll talk about parabolas with their vertex elsewhere later, but we're right now, all of our vertices are at the origin. And then, which way is this going to open? To the left. Yeah, it's got to open away from the directrix and swallow up the focus. And then maybe I'll just figure out, let's see, what's going on when x is negative 2. That's 16. And so y is plus or minus 4. I think I lost you guys. Okay, okay, you're back. I lost you for a second. Alright, so up at 4 here, down at negative 4, and now we can draw our curve. Questions on that example? Okay. All right. So we just worked with some parabolas that are oriented horizontally. They can also be oriented vertically, and the standard form is really similar. We're not going to derive this one, but you could do it. It works exactly the same way as it did when we derived the y squared equals 4px. But if it's oriented vertically, the equation is x squared equals 4py. So we could tell when we look at an equation, first of all, we could tell an equation is a parabola because one variable is squared and the other is not. Right? There's just a single squared variable. We could tell which way it opens based on which one is the squared variable. So if it's an x squared, that opens vertically, up or down, and if it's a y squared, that opens horizontally, left or right. In this next example, they give us the equation x squared equals 4y. I know it's a parabola. I know that it's oriented vertically. We know that 4p is equal to 4. And so p is equal to 1. So if p is a positive, the focus is in a positive y coordinate. Let me just draw a distinction here. So we know it opens upward, right? The vertex is at the origin, it opens upward. That means the focus is going to be on the y-axis, like we see in these like little sketches near the top. So P will give you, in this case, if your focus is at the vertex, or if your vertex is at the origin, P will give you a coordinate of the focus. If it opens horizontally, it gives you the x coordinate. If it opens vertically, it'll give you the y coordinate. What we'll come to find out is that even for a parabola that has its vertex elsewhere, that's sort of located elsewhere in the plane, P will always give you the distance from the vertex to the focus. And so I don't want to get hung up on thinking of the value P as always being a coordinate. When your vertex is at the origin, it does happen to be one of your coordinates. So in this case, our focus is at 0, 1, because it's on the y-axis. And the directrix is the horizontal line this time, y equals -1. And if we sketch it, there's our vertex, our focus is 0, 1, our directrix is y equals -1. And we could get another couple points if we look at, I'm going to go ahead and look at if y is equal to 1, then x squared is equal to 4, and so x is plus or minus 2. So that opens upward. On the next equation they gave us is 2x squared equals -9y. So this one's not quite in standard form yet. Standard form is supposed to be just x squared by itself, like 1x squared equals. So the first thing we'll do is just divide by 2. So -9/2 times y. So now 4p is -9/2. And if we divide by 4 or multiply by 1/4, we get -9/8 for p. Which way does this open? Downward, yeah. If p is positive, it opens upward. If p is negative, it's going to open downward. What's our focus? And the directrix? Yeah, good. So there's our vertex at the origin. The focus is -9/8, so if that's -1, it's maybe like a little bit below it. And if that's +1, the directrix is a little bit above that. And it opens downward. So I'll just, there's a quick and dirty sketch of that parabola. All right, so we're getting the feel of these parabolas, you know, how to find the focus, you know, recognizing when we see an equation of a parabola. Now, in all of these examples, they've given us an equation, and then we got the geometric information from it and sketched it out. So let's do another type of problem. Here, we're going to just turn it around. They're telling us right away that the vertex is not at the origin here. And it says, use the definition of the parabola to find the equation of the parabola with a focus, 2, 3, and directrix y equals -1. So I'm going to say a couple of things here. One, when they say definition of the parabola, they mean that definition we started with that said what makes something a point on the parabola is that the distance to the focus is the same as the distance to the directrix. They're saying, you know, use this idea, that concept there. And then they give us this geometric information. So what I often do, or what I find helpful if I'm starting out with geometric information, is just plotting what I know. So they tell us that the focus is 2, 3. And that the directrix is y equals -1. I mean, all you should need is a focus and directrix. That will uniquely define a parabola. So they tell us that the vertex is not at the origin. Where does anybody know where the vertex is? Can anybody figure that out? Where is it? 2, 1. And why is it at 2, 1? Yeah, right. It's got to be exactly in the middle between the focus and the directrix. Like on that vertical line, you know, if we just sort of draw the line connecting the focus and the directrix, the vertex has to be the midpoint there. Great. So we know what the vertex is. I'm going to right now just sketch this parabola because it's got to open upward, right? We could tell it has to open upward. We know where the vertex is. This is not going to necessarily be an accurate sketch, but I'm just going to say it's got to be something like that. And then I want the equation of this parabola. So I'm going to just say, suppose this point here is a point on the line. So I'm going to call this point xy. Suppose it's a point on the curve, on the parabola. What makes it a point on the parabola is that this distance is the same as that distance. So the focus is the point 2, 3. One of these distances is pretty simple to get. Like this here is a vertical distance. And I know I always get a vertical distance by subtracting the top y minus bottom y. So that distance will be y minus a -1 or y plus 1. For this distance, we can use the distance formula. So that's x minus 2 squared plus y minus 3 squared, all under a square root. And if that's xy is a point on the parabola, then these two distances have to be equal. That's going to get us an equation. So there's an equation of that parabola. Let's try to simplify it. It's not the cleanest looking equation, so let's maybe square both sides. I'll square out the left side, y squared plus 2y plus 1. On the other side, I'm going to get rid, the squaring gets rid of the radical, but then I have those other squares in there, so I'm going to also distribute them. I'm going to also FOIL out those squares. So we get x squared minus 4x plus 4 plus y squared minus 6y plus 9. I'm going to get all my y's on the left side and keep my x's and constants on the right side. So I'm going to subtract y squared. I'm going to add 6y. And I'm going to subtract 1 because I'm going to get my constants on the right side. Then what we're left with on the left side, the y squareds are gone, the constant's gone, we get just 8y. And on the right side we have x squared minus 4x, and then plus 4 plus 9 is 13, minus 1 is plus 12. And we could divide by 8 or multiply by 1/8. So we get 1/8 times x squared minus 4x plus 12. You could distribute the 1/8 if you want and have like fraction coefficients. There's y as a function of x. So this can be convenient for writing y as a function of x. It's convenient if I wanted to like plug the equation into my graphing calculator and sketch it out. But if I started with an equation in this form, I'd be hard pressed to just say, oh, this must be the focus and the directrix of this parabola. So we certainly did what they asked. We got an equation that describes that parabola. But it would be nice if we had a nice standard form like we do with the circle, right? With the circle we have an equation where we could just look at it and say, oh, there's the center and the radius. And we do have a standard form. We definitely have a standard form for the parabola if the vertex is at the origin. And as it turns out, the standard form if the vertex is elsewhere is really quite similar. So on the next page, we see how we call this translation of axes. It's sort of like if you take when everything's sort of at the vertex and just slide it around, we call that a translation. But if the vertex, instead of being at 0, 0, is at hk, then the standard form is what we get when we just replace y with y minus k and x with x minus h. Notice that if the vertex is 0, 0, then that standard form reverts to the one we already know, y squared equals 4px and x squared equals 4py. Also, observe that with the circle, we just went straight to the center being anywhere. We didn't start with first if the center of the circle is at the origin. If the center of the circle is at the origin, then it is just x squared plus y squared equals r squared. And if I wanted to move it, I just replace x with x minus h and k with y minus k. So this is how you do a translation of axes for any equation that's in standard form. Replace x with x minus h and replace y with y minus k, where hk is, in the case of a parabola, the coordinates of a vertex. In the case of a circle, the coordinates of the center. We know if it's oriented horizontally, it's going to be the y that's squared, and if it's oriented vertically, it's going to be the x that's squared. So if I wanted to find the equation of the parabola with vertex 2, 4 and focus 4, 4, well, they start by giving us geometric information, so I'm going to sketch this first. I'm just going to plot those points. I probably can't sketch the whole parabola here, but plotting the points might give me some insight, a place to start at least. So the vertex is at 2, 4. The focus is at 4, 4. So there's the vertex, there's the focus. What does that tell me? It's got to open to the right, so that means it has to be oriented horizontally, and so that means that if I'm finding the equation, I've got to start with the top one, right? It's going to be that guy. Anything else it tells me? Yes, so the Directrix. So let's see, use the sketch. Just want to kind of mark this down. One, that it's oriented horizontally. Two, you said to find the Directrix. So what is the Directrix? Is the y-axis. Yeah, so that's x equals 0. And how did you get it? Yeah, and that distance was 2, right? So this distance from the vertex to the focus, the directed distance, so the focus is to the right, so it's a positive distance, that tells us what p is equal to. So in this standard form up here, 4p times x minus h, we know that p has to be 2. So that's the other thing we get from this. So I know I was starting with y minus k squared equals 4p x minus h. They gave us the vertex, so that's our h and our k. The vertex was at 2, 4, so that's y minus 4 squared equals, we know that p is equal to 2, so 4 times 2, x minus h is 2. So y minus 4 squared is equal to 8 times x minus 2. And there it is. That's the standard form. How's that? We have about 10 minutes left, is that right? Okay. I think that is enough time to do this last example. Are there questions on this one first? Okay. So if I have an equation that's not in standard form, and I want to get it in standard form, we're going to do our favorite thing ever. We're going to complete the square. So we'll note that when, with a parabola, because only one variable is squared and the other isn't, if only one variable is squared, I only have to complete the square in that one variable, right? With the circle, we had to complete the square in both because I had both an x squared and a y squared. So what I'm going to do now to start, since in this case, I only have to complete the square on x. So I'm going to keep the x squared and the 4x, and I'm going to get everything else on the other side. So I'm going to add 9y and add 16. By the way, looking at this equation, how do I know it has to be a parabola? Yeah, one variable is squared, the other's not. Which way is this parabola going to be oriented? Yeah, because it's the x that's squared. Now I'm not quite ready to complete the square yet. What do I need to do first? Yeah, and in fact I'm going to just divide out that 2 from both sides. So we got x squared minus 2x. I'm going to leave space now so I can complete the square next. And then we have 9 halves y plus 8. To complete the square, what's our next move? Yeah. So, and then what do we have on the left side once we do that? Yep. And then we have, just to simplify this side, so 9/2 y plus 9. Now we have completed the square. It's not quite in standard form because this side right here, the right side, I want that to look like some constant times, y minus k. So I want a 1y minus something inside the parentheses. So whatever the coefficient is on y over here, I'm going to factor that out. So we're going to take out the 9/2. The first term is very clearly going to be y. And then what do we multiply by 9/2 to get 9? That's just 2. So there's the standard form. And now we just want the vertex and focus. So what's the vertex? (1, -2). And then for the focus, we have to find P, which won't be that hard, and then use the fact that P is the directed distance from the vertex to the focus. So, okay, we know that 4P has got to be equal to 9/2, and if we multiply both sides by 1/4, P is equal to 9/8. It's a positive 9/8. This is a parabola that opens which direction, up or down? It opens upward. So that means that starting from the vertex, I'm just going to go 9/8 units straight up. So the focus will have the same x-coordinate as the vertex, right? Like if here's the point 1, -2, there's the I'm going to go up 9/8. So the focus is going to have the same x-coordinate. The y-coordinate of the focus I'm going to get by taking my vertex x-coordinate, -2, and then adding 9/8. So -2/1 plus 9/8 is -16/8 plus 9/8, which is -7/8, I think. And there's our vertex and focus. How's that? Okay. Great. Questions before we adjourn for the day? Okay. Great. Well, then I'll see you guys tomorrow. Tomorrow we'll talk about the ellipse, and I'll take questions that you have on, we covered a lot of material today, so the first part of class is always to go over questions you have. So as you're working on exercises, please, come prepared with any questions you might have. We'll start there, and then we'll talk a little bit about the ellipse. We'll have a quiz Friday. Oh, do we, wait, tomorrow's Thursday? Yeah, you know what? I initially thought Monday, Wednesday, Friday, because that's how they put it in my schedule. But I think I could do Monday, Wednesday. I guess it just depends. Do you want your quizzes on Thursdays or Fridays? What do you want to do this week? Well, I guess I'm throwing it out to the class. Do you guys have a preference? Let's just decide this for this week. This quiz that you've decided that you want to have this week. Do you want to take it tomorrow, or do you want to take it Friday? Okay. Then can we meet tomorrow as a class? Does that work for you? Okay. All right. Yeah, so let's meet tomorrow, and then we'll talk about like how we want to go going forward. I think Monday, Wednesday, Thursday will probably work okay for me. And yeah, let's just talk. We'll figure out that details going forward. Great. Thanks, everybody.